Quantum computing, humanity's next big breakthrough. Quantum computing is nothing short of revolutionary. Really, it might be humanity's most transformative breakthrough since we first harnessed fire. But here's where it gets controversial. Can a technology so abstract and complex truly match the scale of an invention that shaped civilization itself? Recently, analysts at Bank of America took a bold stance, comparing quantum computing to fire, one of the earliest monumental leaps in human progress. They emphasized how this cutting-edge technology, which utilizes the strange behaviors of subatomic particles to crunch data, could propel us light years beyond the limits of traditional computer chips made from semiconductors. Bank of America researchers described quantum computing as the biggest revolution for humanity since discovering fire. Imagine a tool capable of performing infinitely complex calculations instantaneously, speeding up our collective knowledge and innovation at warp speed. Fire, after all, was a game changer when early humans learned to control it hundreds of thousands, perhaps even over 1 million years ago. It transformed survival, cooking, and social structures. So the question stands, could quantum computing have a similarly seismic impact? Theoretically, yes. The potential is vast and includes breakthroughs like designing novel drugs, crafting new materials, extending human lifespan, improving encryption security, and revolutionizing logistics. And this is the part most people miss. Quantum computing and the artificial intelligence boom we're witnessing right now could supercharge each other. According to BofA, generative AI can accelerate the development and testing of quantum systems. And in turn, this might boost AI training methods to levels approaching artificial superintelligence, far surpassing today's capabilities. Significant milestones have already been achieved. For instance, in 2023, Google announced that its Sycamore quantum processor completed a task in 6 seconds, a calculation that would have taken the world's fastest supercomputer roughly 47 years. Then, in December, Google's newer Willow quantum chip tackled a problem in under 5 minutes that otherwise would have taken a conventional supercomputer an unimaginable 10 septillion years. That's 10 followed by 24 zeros. However, Bank of America points out a crucial caveat. So far, quantum computers have not outpaced classical computers in solving practical real-world problems. The main challenge lies in qubits, the quantum equivalent of bits, which suffer from noise and errors due to environmental disturbances impeding reliable calculations. Industry insiders echo a tempered view. NVIDIA CEO Jensen Huang stated in January that the most thrilling advancements in quantum computing probably won't arrive for more than a decade. By March, he cautioned against inflating expectations, emphasizing quantum isn't about instantly revolutionizing everyday tasks like spreadsheets. Similarly, Rob Shulkoff, co-founder and chief scientist of Quantum Circuits, described the evolution of quantum technology as gradual rather than explosive. We're steadily turning up the volume, he said, and while we can start to hear the music now, it will take time before everyone can enjoy it. Beyond scientific and commercial implications, BofA highlights quantum computing's geopolitical stakes. Currently, the U.S. leads global semiconductor and computing technology. The nation that dominates the quantum race could gain unmatched technological, economic, and strategic advantages that reshape international power structures. What do you think? Is quantum computing truly a breakthrough on the scale of fire? Or is this comparison an overhype? Could this mysterious technology live up to the lofty promises? Or are we placing too much faith in science fiction becoming reality? Share your thoughts and let's start the conversation. Quantum Advantage Explained. The path to beating classical computers. Imagine a world where computers can solve complex problems that are currently unsolvable. A world where quantum computing reigns supreme. But here's the catch. We're not quite there yet. For years, the concept of quantum advantage has been a moving target, with some claiming it's just around the corner, while others remain skeptical. But what if we told you that a new study from IBM and Pasqal has proposed a testable, criteria-based framework for defining quantum advantage? This framework emphasizes verifiable outputs and measurable improvements over classical computing. And it's about to change the game. The study identifies 3 problem types: sampling, variational algorithms, and expectation value calculations. as the most promising paths to near-term quantum advantage. But here's where it gets interesting. The authors argue that progress depends more on error management than algorithm design. They highlight hybrid quantum classical systems and hardware platforms like superconducting circuits and neutral atoms as key enablers. So what does this mean for the future of quantum computing? The researchers propose a middle ground between hype and skepticism, where quantum advantage is not just a theoretical concept, but a practical and testable goal. They argue that establishing trust in the outcome of a computation is crucial, and that this can be achieved through three strategies: computing error bars using fault-tolerant circuits, leveraging problem types that allow for efficient classical verification of results, and variational problems where quantum algorithms output a number that can be ranked against known values. The study also identifies three classes of problems most likely to deliver early quantum wins: sampling problems, variational algorithms, and expectation value calculations. But error handling is the biggest obstacle to quantum advantage, not algorithm design. The framework breaks error handling methods into three tiers: error correction, error mitigation, and error detection. The researchers argue that hybrid strategies, combining quantum circuits with classical post-processing and high-performance computing, will be key to achieving quantum advantage. And this is the part most people miss. Hardware still limits the field. The paper singles out superconducting circuits and neutral atoms as the most likely platforms to achieve early advantage. So what's next? The authors urge the field to adopt clear, testable benchmarks and emphasize that any claim of quantum advantage should be framed as a falsifiable hypothesis. They expect the conversations and arguments about quantum advantage will likely increase soon. And here's the million-dollar question. Will we see incremental wins in the next 2 years? Or will classical methods continue to outperform quantum algorithms? The researchers expect the credible evidence of quantum advantage is likely to emerge in one of the areas highlighted in the study, enabled by sustained coordination between the high-performance computing and quantum computing communities. But we want to hear from you. Do you think quantum advantage is just around the corner? Or are we still far from achieving it? Share your thoughts in the comments below. Quantum computing breakthrough, cloud, AI, and the future of tech. IDTechEx Insights. The realm of quantum computing is on the brink of unlocking unprecedented commercial potential, with projections indicating that the hardware market could surpass a staggering $21 billion by the year 2046. National governments and leading technology firms are actively formulating their quantum strategies, gearing up to leverage the first generation of machines that will tackle critical computational challenges across various sectors, including high-performance computing, HPC, pharmaceuticals, automotive, and many more. In an insightful webinar, IDTechEx technology analyst Noah El-Alami delves into the essential aspects of the quantum computing landscape. He articulates the unique value proposition that quantum computers offer, particularly in relation to artificial intelligence, AI, and cloud services. Furthermore, he explores the current proximity of quantum computers to addressing commercially significant problems. This engaging session addresses several pivotal questions, such as: what fundamental advantages do quantum computers provide? What are the primary methodologies being pursued to develop a commercial quantum computer? How are major players in the tech industry like Microsoft, Google, and AWS approaching the quantum computing challenge? Do quantum computing and AI serve as rivals, or do they complement each other? How imminent is the realization of commercial value from quantum computing? The insights shared in this webinar are drawn from the comprehensive report titled Quantum Computing Market 2026 to 2046, Technology, Trends, Players, Forecasts. This extensive document offers detailed profiles of leading companies, in-depth technology analyses, and forecasts spanning 2 decades for 8 prominent hardware approaches: superconducting, trapped ion, neutral atom, photonic, silicon spin, diamond defect, topological, and annealers. But here's where it gets controversial. As the race for quantum supremacy heats up, will the benefits truly outweigh the challenges? Are we ready for the ethical implications that come with such powerful technology? Join the conversation and share your thoughts in the comments below.